All right, everybody, let's get started. Hopefully you can hear us on channel 3. My name is Jake Woodhams. With me is James Saturnio, who's a senior solutions architect out of our corporate office. Also here, Dave Hunt, senior technical marketing engineer. Myself, as I mentioned, I'm Jake Woodhams. I'm a senior director of technical marketing and solutions architecture. The presentation we're going to be delivering here or talking about has to do with understanding the security differences and the implications of those differences and how we manage and secure different mobile devices. So as you know, we have 3 major platforms that we support at MobileIron, or that we really focus on. Specifically, as you can see on the left-hand side, Android. The middle, of course, iOS, which is perhaps our most mature and most common platform. The right-hand side coming on very strong now, Windows, and specifically Windows 10. Now, as you know, all of these different platforms have a variety of different, or have approaches to security, and yet we're all trying to do the same thing with these mobile platforms, specifically in how we secure them. So we're going to go through a number of different categories here, as you can see in this circle, starting talking device access and encryption, through identity, app management and security implications around app management, containerization and DLP, or data loss prevention, data in motion, tunnel VPN technologies, and then finally talking about malware threats. And what we're going to do is we're going to go through and talk about how our aspiration, or our goal ultimately, is to take a unified management and security approach or posture towards all of the different platforms, and yet there are different nuances there in the platforms, and we're going to highlight, or try to highlight, those differences and talk about different ways you can be successful across a multi-OS deployment. All right, so let's start off talking about device access and encryption. All right, so James.
So what you have here is a security policy, and this is taken from the MobileIron core. And the first step to encrypting, doing a full device encryption, is to set a passcode. That could be a password, complex password, that could be a PIN. And we're going to also talk about some biometric features also. But the first step that you need to do is create a passcode for your device. And here you have an example where the password is mandatory, and the minimum password length, and with complexity, those elements within the password themselves also. What we would recommend is probably 8 characters or greater, with a minimum of maybe 3 or more complex characters in the password. So this is the first step.
Yeah, you know, with the acknowledgement that 8 characters or more is often a very difficult, right, for people on mobile devices, right? So you got to look at the trade-off between what's absolute security versus, you know, what's actually usable for the end users, and so on, right? There's also, you know, tied in with this conversation about passcodes and so on, a lot of questions often come in about biometric type of controls. Obviously, when we talk iOS and Apple Touch ID acts as an effective alias to the passcode, or the device passcode. And so that's very usable, it's secure, very practical. We'll talk, you know, about App Connect a little bit later on, but you can use that Touch ID as both a device as well as a passcode to the app container there. Other platforms, it's a little bit different when it comes to biometric controls than Apple. I'm a most expert on Apple. James, you've been working with Windows and things like that.
On the Windows side, yeah.
And Android.
Well, you know, of course, you know, with Android, you know, you have to have encryption, and new devices that are being deployed today, you know, are leveraging, you know, they come out of the box encrypted for, obviously for Android, for work to even function. So, well, you know.
And on the Windows side, well, on the Windows side, the biometric support is not quite there yet. It's called Windows Hello. It's a little different approach. It's not fingerprint, it's facial recognition. So you can probably see a bunch of people holding their phones up really close to their face on Windows devices.
Or your Surface tablet, you know. Right.
So,
Yeah.
but it's not there yet. So,
Yeah. Right.
and then the next step, again, as part of the security policy, is enabling data encryption. And on Windows devices, if you haven't noticed, I'm Windows. He's iOS, he's Android for work.
White guy's
So,
Android.
Yeah, right.
so on the Windows side, with data encryption, Windows Mobile comes encrypted out of the factory. Windows Desktop, you have to turn on BitLocker. And again, this is a full device encryption. The only difference is on a Windows device, the SD card cannot be encrypted.
In the case of iOS, the encryption is triggered based on the device passcode. Probably saw a lot of that coming, the different conversations surrounding the San Bernardino scenario there with the device passcode and the device encryption. And so really for iOS, if you want to enforce encryption on the device, enforce the passcode, and that's all you need to do to enforce the encryption. Now there's an additional layer of encryption you can apply through App Connect, which we'll talk about a little bit later on, but in general that device-based encryption, passcode equals encryption, and of course things like SD cards and peripherals don't really apply in the iOS world because it's a self-contained or closed unit. Now Android...
Yeah. With Android, you know, you talk about that layered approach that they do, and encryption is part of that layered approach. With that, they have, you know, the idea is that when your application comes up, you're using the same binary on both sides for
This is
Chrome.
Android for work.
Right, and this is the way Android's moving into the enterprise. But you bring it up, the data itself is encrypted, and only the application, only does it come, when it's at rest, it stays encrypted on the device, and that's part of their layered approach to security. So,
All right. So that
was
takes
fun.
us through our discussion on access and encryption. Again, passcodes, device encryption, pretty basic stuff, yet fundamental to this kind of defense in depth or layered security approach. Now what we're going to do is we're going to talk about identity management. And in this conversation about identity, what we're talking about specifically here has to do with certificates and the provisioning of certificates on the device for a variety of different purposes, whether that be service or enrollment, as well as a variety of different services like Wi-Fi, VPN, email, and so on that we may want to do. Now, you'll notice that we support now a wide variety of CAs, including our own on board. I'll let you talk to this as cert man. Yeah.
Sorry. So for and this is specific to Windows 10. And I'll make a caveat for Windows Phone 8.1, but for all three platforms, including Windows 10, we now support the MobileIron local CA and the intermediate CA. That wasn't supported previously in Windows Phone 8.1. Now we support the MobileIron local CA and the intermediate. We support this says Windows Server 2012, but it's Windows Server 2008, 2012, R2. The certification authority is now supported in all three platforms, including Windows 10, as it always has. We support Entrust, CA. We support OpenTrust, which is now called ID-Nomicon. They changed the name to protect the innocent. Both flavors of Symantec. And we support PFX being a PKCS12 formatted certificate, which basically has the public and private key pair protected by a encryption using a password. So we can now push these types of certificates onto all three mobile devices. In the case for like PKCS12, that could be for S-MIME, for email encryption and signing, and for ADFS support.
Okay, so this slide would apply to iOS 9, but because of our qualification, this is all three of our OS platforms, right? And as you qualified before, Windows Phone 8.1 would only be supported by Windows CAs, right?
I can go into more detail about that, but in Windows Phone 8.1, there's still quite a few devices out there. The only supported CA, certification authority, is Windows, and that being the NDES, or Network Device Enrollment Service, to a back-end Windows PKI. So that is the only supported certification authority. But Windows 10 changed the playing field, and all of these are now supported in Windows 10.
Which brings us to an interesting couple of new terms that we should define and qualify here, right? As of Core 9.0, we have these two terms you may run across: centralized, decentralized.
Yeah. So
do you want to decode these? Or?
Yeah. So
I
Core
tried
9.0.
to explain these, and he goes, no, it's not like that. So go ahead.
So think of centralized as the old legacy SCEP proxy. That means that the core is generating the certificate signing request and the asymmetric public and private key pair on behalf of an iOS and an Android device. Core is the one that's generating this CSR, the asymmetric key pair, and goes out and gets a certificate on behalf of the mobile device. That is centralized.
And we did that because early iterations of iOS and Android didn't have native SCEP clients built into the OS. So to do this dynamic cert provisioning, right, we had this solution.
Didn't or don't.
Yeah, so this has been there since like MobileIron Core 4.0 or whatever, but we just started calling it centralized.
Centralized.
Right.
The easiest way to remember this is centralized. Core is the client. In the case of decentralized, and really there's only one use case that I can think of that you would use decentralized, and that is the legacy support for Windows Phone 8.1 when we introduced a term called SCEP reverse proxy. Let me explain why this is so. Microsoft makes it a point that their devices you cannot export the public or private key pair, specifically the private key. You can't export it from the mobile device. So that means that the mobile device has a built-in SCEP client and generates the CSR, generates its own key pair. It's great for non-repudiation, right? So Windows Phone 8.1, that is the only supported method, and really what it is the mobile device, again, sorry I'm repeating myself, but the mobile device generates the key pair, the CSR. Core acts as a transparent proxy. It just forwards the request to, in this case, it would be a Microsoft CA. It just forwards it, and the identity certificate is forwarded back to Core. Core basically bundles everything and forwards it to the Windows device. So decentralized, think of it as really, it's acting as a proxy for the mobile device. And the only application you would need to use this is for Windows Phone 8.1. Windows 10 also supports this, but Windows 10 also supports centralized because it now supports all of the other CAs. So is that clear as mud?
About that, SCEP has been an excellent blessing for us in terms of dynamic cert provisioning. But for some of us, our legacy, actually all three of us worked for this company that made those big green teal networking boxes. In the past, that company actually invented this thing called Simple Certificate Enrollment Protocol, but it was designed for network hardware. It's been adapted to the modern world, but we've had to deal with some of the nuances of that. Moving forward, though, we talk about you'll probably, as if you visit the IoT booth, or as we start to talk more IoT right over there, or go to James's IoT presentation, you may hear something about EST, which is a different type of approach to enrolling devices and cert provisioning, and it's all based on elliptic curve cryptography, which happens to be one of James's hobby horses, and it's something that's now in iOS 9. In Core 9. Sorry.
Core 9, yes.
Yeah.
In Core 9, basically, we now support elliptic curve cryptography for the asymmetric key pair. Everyone's familiar with RSA, and the caveat with RSA is to secure data in motion, data at rest, the keys will get longer. But that requires a lot of computational effort or computational power. And the beauty of elliptic curve cryptography is that for a shorter key length. So this table actually shows you that in the elliptic curve realm, a key.
Oops, sorry. I was not supposed to press that button. You didn't know what it did, and now we do, right? So this is what you're talking about right here.
The key length of 224, that's bits, is greater or is equivalent to or stronger than RSA 2048-bit keys because the entropy source is better. An entropy source is basically it's the randomness that you generate, put everything together. So for elliptic curve, the entropy source is better than RSA. That's why you can have shorter keys. And the beauty of elliptic curve is because these keys are much shorter, the computational power is much less. The storage capacity can be much less, and that's in line with IoT, right? Because you have these things, you have these devices, you have limited storage, limited even bandwidth for networking. Normally it's something like the MTU being like 762. So elliptic curve is really, it's geared for the Internet of Things. And it's beautiful for mobile devices too because it is more efficient than RSA. And the last thing is, elliptic curve, according to NIST, is going to be good, especially 256-bit keys are going to be around for the next 30 years. With RSA, key length is going to keep growing.
So James, are you telling everyone to move in this direction, right?
I mean, it's a whole, it would be a different deployment. Basically, mobile devices, things would have to re-register to obtain the new certs. It's a whole new cert, that's what it is. So, but the beauty is, we now support it in our local CA.
But so you know, ultimately, if we've got an existing plant, stick with the crypto that you've got. But you know, if you're looking at any greenfield deployments, ECC might be something worth considering.
Yeah.
All right, now, and also new in 9.0 is certificate revocation and management, right?
Yeah.
Which is a kind of a key thing. That'll work across all of our OS platforms, right?
Yeah, exactly. So the certificate of management lifecycle can now be managed within the core itself. And this is both for local CA as well as external, where you can actually revoke, remove, and renew. If you happen to notice, that's Jake's name up there. So
I'm trying to figure out why he wants to revoke all of my
boss,
certs, right?
If he pisses me off, I think I'm
Yeah, right.
no. So now you can manage external and internal CAs from within core.
All right. All right, so that goes through the certificates and so on. Now, we'll move into talking about apps where things get a little bit more nuanced and so on when it comes to managing them. One thing, when you talk about corporate-owned use cases, is the notion of blacklisting or whitelisting different types of apps. Now, this is not something that's always been the easiest thing to do. In the iOS world, typically you've been able to essentially require apps, but not until iOS 9.3 implemented actual MDM controls for whitelisting and blacklisting apps. Now, we don't support that in iOS 9.3 yet on either core or cloud. That is a future. But you can find out details. We've actually got a demo where we've done some stuff with custom XML over at the Answers bar. There's a demo center. I'll also be talking about this in my other presentation tomorrow on iOS 9.3. Windows actually has done quite a bit here with blacklisting and whitelisting of apps.
Yeah, so on the Windows side, they actually call it App Locker. And it is basically, it's the blacklisting and whitelisting. And what you're seeing here is an actual blacklist that's generated for a Windows 10 device. The key thing that you notice is the app identifiers. That's sort of the unique thing. Microsoft requires that for Windows 10 devices. Generally, the PFN, or the publisher family name, has to be used to identify the app in a blacklist or a whitelist.
Yeah, it's like App ID
App ID,
on the
exactly.
iOS side.
Right? And then on legacy or on Windows Phone 8.1 devices, they use a GUID, a globally unique identifier. So why did they change it up? I don't know. But the beauty of Core, and even on Cloud actually has a slightly better presentation than this. If you actually enter the app ID, or normal string in the app identifier name, it'll actually go off to the Windows store and get that PFN or GUID for you. So you don't have to try to remember these things on core. So yeah, this is actually an example of a blacklist for Windows 10 device.
And what about Android here?
Well, Android, I mean, obviously, as you move to Android for work, we don't have a DPC agent in the personal profile, so we don't have any concept of what apps are allowed or blacklisted in the personal side, only in the work container, and that shows up in the app catalog itself. But in a normal Android or pre-Lollipop deployment, it's the same scenario. You've got the capability to whitelist and blacklist apps, just like he's showing here. Just a different format.
And I guess in a scenario where you've got a corporate-owned contained kiosk type of application,
yeah,
right, where you really want to control or blacklist apps, you might use an Android for Work device owner or something like that.
Oh, exactly. And the only apps that you can even see are the apps that are that you permit. There's no visibility of those apps outside that work profile. No way to grab them.
Another piece of app security, obviously, is app curation. So the only thing we really want to highlight here is you have your curated app store or whatnot. The approach is slightly different across platforms, of course. Of course, on the iOS side, we have to drop a web clip as an apps at work, or you can use the in-house apps at work as your curated app store, if you will. Android, we do this through the mobile at work client.
Exactly. Yeah, we still use App Connect. I mean, everyone's usually asking us when we're going to use the badge Google Play, but mobile at work includes apps within as an apps apps at work are included in mobile at work on the Android platform.
Right.
On the Windows side, on Core 9.0, apps at work actually comes with Core. So as soon as you at runtime, apps at work is actually listed as one of the apps for Windows, Windows 10, Windows Phone. So you don't have to actually import it as an in-house app.
All right. So moving forward, these have all been focused around different types of functionality that would be native on the device, different approaches. Now, of course, a key problem we've had to address in the mobile space has to do with app containerization or data containerization and DLP or data loss prevention. We'll talk about the App Connect program here. Hopefully you're all familiar. If not, I'll kind of give an overview here. App Connect has been something we've been featuring and rolling out on the iOS side and Android for a couple of years. I believe since, well, really early 2013.
September 2012.
September 2012. And the idea there is you provide an SDK or an app wrapper. On the Android side, there's only a wrapper option. On iOS, you have a wrapper and an SDK that app developers can use to implement certain in the proprietary MobileIron technologies for security. And there's a lot of different aspects to this. First and foremost, because the device is tied to a user and that user is authorized to run an app, there's an authentication and authorization component of App Connect. There are policies that can be put into place that apply to the app itself. There is an additional ability to, if you're using on the iOS side, the SDK to implement a separate layer of independent encryption for the app. But that actually requires some development work. We just have not seen enough use cases where people said, we absolutely need that extra layer of encryption over the device, and it's there. Now, believe it or not, there's also a little API you can call on the MobileIron core, which will give you some analytics information about a particular App Connect app. For example, how long it's been in the foreground, and so on. And then, of course, the ability to do the selective wipe of the apps and data in the container. All of that creating this App Connect solution. Now, you'll hear us talking this week about App Config Community, and that's because what we're seeing trend-wise and what we endorse as MobileIron is that the move of a lot of these kind of capabilities and functionalities into the native controls on the device. So DLP controls configuration controls and actually some of the tunneling controls you get on the iOS side can now be done in a number of different ways via native controls. They may not be as granular on the DLP side. The app tunneling, you can have much more granular rules, but it's also less flexible because it only applies to HTTP traffic. So in general, and then on the Android for Work side, or the Android for Work, we see that move of a variety of restrictions and so on built into the app via the metadata that
Right.
Google mandates.
You know, the nice thing about, outside the container, when you run Android for Work, you can run any app that exists in the Play Store, right? But when it's a wrapped, it has to be wrapped. It has to be a brand new and separate application.
Yeah.
So I mean, the App Connect program, like I said, started in September 2012. It was MobileIron's reason, or we knew Android needed to be into the enterprise, but it wasn't secure enough as it stood. When you think back to KitKat, there really wasn't anything there to make it, ready for the enterprise. And I'd say pretty close on the heels of App Connect came Samsung Knox. The advantage that Knox brings to the table is that they own the hardware. It doesn't exist on every piece of Samsung equipment, but they do have an ability to control many APIs, and many of those APIs do run across all the Samsung devices, but you're limited to the Samsung device. But that framework, when you think about that migration to an open standard, an open initiative with across all vendors, no matter who it is, now you've got this Android for Work framework that does many of the things that you can do in Samsung Knox without the capability of manufacturing the hardware, but it gives you, any application can go into that work profile. Only the applications you want as a network or mobility administrator can go in that profile. The data, when it's at rest, is encrypted and stored down there in the hardware. It brings a lot of what we need into focus. And we'll circle back on this, but when you think about it, as we move up, as we move from Marshmallow to, I'm going to call it Nutella, I don't know if they actually came out with a name yet, but as they moved, you'd have to rewrap that app because now it's a new operating system if we were doing a wrapped app. Now with Android for Work, as it's down to the OS level, so they differentiate it, call it a profile versus a container. Container is wrapped apps, so the application's wrapped. The profile, I'm doing it in the OS and I separate the work data from the personal side of the house. We don't have any access or any APIs to touch the personal side, but we have all access to remove the applications and the data from the work side.
Yeah, so in general we'll continue to develop and support App Connect for both iOS and Android. Part of the reason, the real reason on Android, we've got a mandate from business. Google was pushing forward with this thing called Android for Work app, which would have applied some of the Android for Work logic to Android devices that were not natively capable of running the Android for Work profiles. They've subsequently kind of stopped progress on that project. So for devices that can't support Android for Work, we need to have a containerized solution in App Connect. On the iOS side, we have an ecosystem of partners that have built things around App Connect, and there are things that we can do in App Connect that we can't do with native controls. For example, iOS DLP controls will only give you a coarse-grained open-in from managed app to managed app as a control. Whereas on the App Connect side, you could actually define a specific whitelist or blacklist of apps within the container. You could also provide DLP controls with App Connect around cut, copy, paste, which you can't do with native iOS controls. But in general, you probably don't need that kind of sophisticated granular security for the requirements you have, and the native controls will be good enough. And ultimately, we think that you heard the GE presentation, an example this morning where he said, look, if every time, in our experience, every time Apple has done a major update to iOS 8, to iOS 9, we've had to go through and respin our wrapper. We've had to update our SDK. All of your App Connect apps then have to either be rewrapped or recompiled to support the new operating system.
Yeah.
That's not the most manageable approach because you really can't stop mobile devices from upgrading.
And
Now
so-
Windows,
Well,
Go
yeah,
ahead,
just going to say, certainly you can see the reason why we support, the standardized approach rather than, proprietary approach.
Yeah. Now Windows takes an slightly different, which we've never had App Connect for Windows. There's a reason why.
Yeah, so on the Windows side, they have it's enterprise data protection, and there's an asterisk there. That means it's still TBD. Part of it is because Microsoft has been talking about it for the past year, but up until recently, they've actually provided an actual build that has EDP running on it, but of course it still has to be vetted by us to make sure that it actually works.
Yeah.
So that's why it's an asterisk.
Yeah.
We're talking about it because again, it's similar to all the other container solutions where you have you're basically isolating your work from your personal personas, and in the particular case, again, you cannot share or copy anything from your work or your work side to your personal side. So right now it's still TBD at this particular point.
Be clear, we're being recorded, so this is the future, right?
Yeah.
You saw the disclaimer this morning. Don't buy based on promises here, right?
Yeah.
But it is Microsoft's approach
Yeah.
to this sort of separation of personal and work data built in natively to the system, and
Yeah.
hopefully it will be, really good, right?
Yeah, I mean, one of the
It looks good when you read the white papers and so on, right? So.
One of the minor things, and again, as Dave mentioned about Android for Work, there's the concept of, as far as presentation on the device goes, you have a badged app, and then you have the native app. But it's really, it's the same app. The approach for Windows is it's one app, but the data that it creates is actually separated for work or
being a difference, I mean, I have a Chrome and a badge Chrome, the same binary underneath that, but on Windows, we're talking one icon,
Yeah.
two sets of data, right?
So that's the only, maybe a different.
So it's sort of a nuance, if I'm understanding what you're saying. The Android for Work side, you got the same binary, data is shared, but the operating system is passing it through a virtualization layer to present it differently on the presentation layer to the end user between badged and unbadged. Windows, we actually, one binary, two completely independent sets of data, right?
Exactly.
Right. Okay, good. All right, now, that kind of goes through our containerization and data loss prevention overview there, which takes us into the discussion. Now, I'll segue into this discussion around data in motion security, which is really the per app VPN and the VPN technologies. One of the things that our App Connect program provided was this app tunnel, which was the ability to do something that looks a lot like a per app VPN for HTTP traffic. Now, if you compiled or used the wrapper for either Android or iOS in an App Connect world, we actually would insert some logic into the protocol stack. So if you were making a protocol call, we could trap that HTTP call and map that to a set of tunneling rules, and based on those tunneling rules, use the Sentry as a reverse HTTP proxy that looks a lot like VPNs. Now, Apple subsequently introduced per app VPN as a native control into the system. There are similar things on the Android and Windows side, which brings us to Tunnel, which is what our implementation or version of these per app VPN technologies using native or embedded controls. So James is the Tunnel expert. He's written the white paper, right? So so.
Okay, so what you're seeing here is basically, this is Tunnel for Android for Work, for iOS, and for Windows. And the next slide will actually go over some of the differences between these MobileIron Tunnel VPN implementation. This is an actual VPN. It's actually SSL VPN. So that's a key difference. Sorry for the eye chart here. In one of the previous...
take a picture of this one, right?
In one of the previous presentations, this was actually there. This is just the comparison, and the only difference with the previous presentation is I included Windows Phone 8.1. I've removed it here because the focus is now on Windows 10. So the key takeaways from this, again, is the fact that for Android for Work, for iOS, for Windows 10, self-activation, the only one that is self-activating is Windows 10, and also for Windows Phone 8.1. You have to manually activate both for Android for Work and iOS. Another key takeaway here is the fact that currently the version of Tunnel for iOS still only supports TCP at this point. Last year in WWDC, iOS also supported, or now supports UDP, but it's still not been implemented in our MobileIron Tunnel application. But for Android for Work and for Windows 10, both TCP and UDP streams are supported at this point.
I'd just add, to the fact that, this is a clear example of how, Android for Work came out last March, and now we're about, 14 months into the program, and when you think about it, things have constantly progressed. Android N is promised to even bring further advancements, specifically into the capabilities of what we can do with Tunnel and other VPN technologies. So.
Yeah, and another thing there is the split tunneling support. So in some use cases, split tunneling is required. So at this particular point, Android for Work supports it. Windows 10 supports split tunneling. iOS still TBD.
And then maybe one thing we want to talk about is the app triggering versus...
Oh, that's right. That's an important thing.
Yeah.
There's a concept of app triggering. For Windows Phone 8.1, I'm going to try to talk a little slower here. There was both the app-based triggering of the VPN tunnel and also IP-based triggering. Domain was not supported. That was a Microsoft issue. For Windows 10, right now, it's only app-based triggering. That means when you fire up an app, like Edge, the Edge browser, or RDP or something like that, that is what's going to trigger the VPN tunnel. For Android for Work, right now it's manually triggered. It means you have to turn it on. And as Dave mentioned, hopefully at some later point, it will be triggered via app, IP, or domain. iOS, it's per app that's triggering the VPN tunnel.
That's correct, yeah. Per app based on the domain rules. Now, in general, people have expressed a desire to, I'll go ahead and build this out, to use the per app or the app triggered type of VPN approaches in mobile because it's far more lightweight than your traditional third party or your traditional VPN type of approaches. However, there are scenarios where third party VPN or traditional VPN approaches are necessary, as well as IPsec type VPNs as opposed to SSL VPNs. And so, this is a chart that looks through the different types of VPN or third party VPN support that's there. Again, James has done a lot of lab work in this area.
Yeah.
He's said a lot of words we can't repeat from this platform. I sit next to him in the corporate office, and
So one of the use cases for using a third-party VPN is if you have the network infrastructure already in place, right? Ideally, we'd want you to use MobileIron Tunnel connecting to Sentry. It's an SSL VPN. So on the Android side, we support OpenVPN. I'm going to go this way, down. The F5 Big IP, the Pulse Secure. Up at the top is the Samsung IPsec client. Next is the familiar Cisco AnyConnect. Underneath that is Juno's Pulse, but Juno's Pulse has been deprecated, replaced with Pulse Secure. Apparently Pulse Secure spun out from Juniper. The Sonic Wall, which is Dell. And then we also support the Aruba VPN and the Global Protect from Palo Alto, but that is within the context of Android for Work as an app restriction.
That's the Palo Alto Networks.
That's the Palo Alto Networks Global Protect. It isn't natively supported for Android, but you can configure it as part of an app restriction in Android for Work. On the iOS side, we support the native v2 IPsec client that comes with, actually came with iOS 8, but it's been carried over to iOS 9. Again, F5, Pulse Secure, Sonic Wall, which is Dell, Cisco AnyConnect. The only difference, again, would be for VIA, the Aruba VIA, which is now HP, and Palo Alto Networks Global Protect and the Checkpoint VPN, they are not natively supported, meaning they're not in the UI, but you can create what is called a custom SSL profile. As long as you know in this case, again, it's only supported for iOS, that's custom SSL. As long as you know the bundle ID of the Aruba VIA, the Global Protect, and Checkpoint, you can configure it. I've tested it, it works. On the Windows side, basically everything that's listed there is natively supported, including Checkpoint. So, and for Windows 10, it is the Windows 10 built-in v2 IPsec client. All the others, they can talk either SSL VPN or IPsec, the other client. So there you have it.
All right, so that is the data in motion component there again. Tunneling, per-app VPN, and then third-party VPNs, which brings us to our final category here, which has to do with malware and malware threat protection. Obviously, this is where a lot of the press is and a lot of the news is around malware and the variety of different malware threats. We are not a malware detection or an app reputation company. We partner with our ecosystem partners to deliver those components. Our focus is continuing to be on security in terms of compliance and policy, access control, and then the data in motion security. But you take these two together and you get a pretty comprehensive approach when it comes to malware. All right, so there's two different kinds of malware detection we could talk to, one being app reputation, and actually, James, you could talk through the nuances of this.
So yeah, there's two approaches for malware protection. That is the malware threat protection, MTP, and there is the app reputation. Really the differences are the fact that for app reputation, in a sense, it integrates with our core appliance. In this case, we have the example here for AppAuthority, where AppAuthority integrates via API to our core, and any devices that are registered with that core will actually be pulled in and to AppAuthority, and the app would be analyzed whether it was risky or malware or okay. The concept of malware threat protection, or MTP, in the case of like FireEye or even AppAuthority or even Verico, they have both, is they have their own portal. They have their own separate portal, which in the case of FireEye, in the case of AppAuthority, it doesn't also integrate with core, but within their portal, you can enforce some additional policies, including the enforcement of if a malware or a risky app is detected. You can not only send a message, but you can actually force the user to actually remove that risky or malware on the device. So the difference is being that malware threat protection has their own portal as opposed to app reputation, which does integrate with our core. And what you see to the right is our ecosystem partners for both app reputation and malware threat protection.
And some of them are here, so
yeah, actually some of them are actually here.
Imperium, Sky, Curation, these other people. So stop by and see them. The key thing here is that most of the threat detection and app reputation that takes place is very much reactive, right? The malware is already on the device. What is valuable about having MobileIron and these different approaches to malware detection or reputation is that we can actually take actions, right? You can define compliance actions, for example, around these different, when you see something around different reputation or malware, we could take action, quarantine the device, we could wipe the device, all these different things that you can do. So taken together, it's a full solution.
Okay.
All right, so that brings us, now when it comes, we were talking about app reputation and malware detection typically applies in first and foremost the Android world and then the iOS. Windows is going a slightly different direction, or actually a major different direction.
Yeah,
here.
It's a little bit of an outlier, especially on the Windows desktop. You like that bouncing Windows 10?
Yeah.
So on Windows 10 desktop, because of the fact that you can load universal Windows apps, or basically these are the sandbox apps, as well as Win32 apps on a Windows 10 desktop. And because of the Windows 30 or Windows 32 apps, you need an antivirus agent. In this case, it's Windows Defender, which comes out of the box. And really, the only reason why Windows Defender is there is because of Win32 apps. Okay, and within MobileIron Core, you can actually make sure that it is enabled. And that could be, if it wasn't enabled, that could be based on a compliance action too. For Windows Desktop, we can control whether Windows Defender is enabled or disabled. For Windows Mobile, it's a little different. Windows Mobile can only take universal apps. So these are sandbox apps. There isn't an app reputation solution per se, like for iOS and Android. Microsoft is coming out with a thing called Device Guard. It was just announced. It will, at some point, hopefully be supported, but that is their approach for the universal apps. So right now, what we have on Core is enforcement for Windows Defender.
Okay.
All right. Well, that brings us here to the end of the overall discussion. Again, we tried to go through the different layers or the different components of securing a multi-OS deployment, starting with access and encryption, the identity and certificate component, apps, obviously the different approaches to containerization with App Connect versus native controls versus enterprise data protection on the Windows side, and then of course the tunneling and VPN approaches, and finally the malware threat. So, taking together all of these things, you can aspire towards a unified strategy and a unified management and security policy approach to managing multiple OSs, even though the underlying instrumentations may be a little bit different. And so, hopefully as we progress and the industry evolves, this will become easier and easier, and that's where we at MobileIron look to continue to add value and help things out. All right, so...
Are there any questions?
Questions? Any questions?